Hi everyone, in this tutorial we are going to learn about 3D printing. Over the past few weeks we've been able to learn how to model different items, and then we've also learned how to create assemblies. In this final tutorial I'll show you how you can actually make it and then use it for something useful. To help me to do that, I'll be showing you how you can 3D print this spare gear with the principles of design logo embossed on it. I'll be showing you how the 3D printer works, and then I'll also show you the various procedures you go through to prepare this model for 3D printing. Let's get to work. Let us begin by understanding what 3D printing means. So a 3D printer is basically a machine that has three motors. And the three motors are able to move on the x-axis, y-axis, z-axis. And when it is doing that, it keeps adding a molten plastic material depending on the shape that you program it to print. So take, for example, this spare gear with the POD on it. If we want to 3D print it, we'll start with a blank bed, and we'll start depositing material from the blank bed, and then it will keep rising up till it gets to this level. So 3D printing is a type of manufacturing called additive manufacturing. Now the difference between additive and subtractive type of manufacturing is, with the additive, you start adding till you are done with the whatever you are manufacturing. But with the extractive, you have a piece of the material, and then you'll be taking the material away from the stock material till you are done manufacturing. So when we compare 3D printing with carving a wood carving, you need a big piece of wood first before you cut some parts of it till you are done with the preferred shape of carving that you want. But with the 3D printing, you start with a blank flat surface and you keep adding molten plastic material till you get this. There are various types of 3D printers on the market. Most of them are depending on the brand or the manufacturer that makes them. Very popular ones include the Prusa i3, we have the MakerBot, we have the Create. Now, there are a whole lot of 3D printers on the market. Some of these include the Ultimaker, the MakerBot, the Prusa, Creality Ender, etc. The 3D printer I'll be using for this tutorial is the Creality Ender 3 Pro. It's a personal printer I use at home for making stuff. Now, the 3D printer does not understand whatever you are doing in Fusion 360. The 3D printer only has three motors: the x-axis motor, y-axis motor, and the z-axis motor. So we need to prepare this model into a format that the 3D printer can understand, in the format, let's say, move left motor, move right motor, move Z motor. To do that, we are going to click on Make, and then we select 3D Print. And then over here, you see a small dialog box opening up. You can change the refinement to how you want it. And then you need to select the body that you want to 3D print. So I've selected this body. Now I can either choose to send it to the software that will help me convert this to motor movements, some of which include Mesh Mixer, Cura, Preform, Print Studio, etc. Or I can export it to a format that I already know, and then I will open the software independently and then do that. I choose the later option. So I will not send to the 3D print utility. I will untick this and then I'll press on OK. When I do this, Fusion 360 will help me save this file into a format known as an STL file. So I'll change this to gear to print, and then I'll click on Save. The next software I'll be using to convert this into motor movements is called Cura. And what Cura does is known as slicing. So it will take this model, convert it into XYZ motor movements, and that process is known as slicing. So you can download Cura from the internet. Just search for Ultimaker Cura. Let me now show you the interface of the Cura. The first icon here is where you can click to open the file that you want to print. So I'll click on it and then I'll select gear to print. The next thing here is the printer that you are using. I have had other 3D printers before, but at the moment I am using Creality Ender 3 Pro. And then the nozzle size is the size of the nozzle or the extruder that you are going to use. And the material that you are going to use, which is the filament, is called the PLA. We have various types of filaments that you can use. We have the PLA, we have the ABS, we have various types. You can Google that and then see. And then the next thing here is where we can modify the print quality. So we can set the layer height of each print to these various values. It can range from 0.12 millimeters to 0.2 up to 0.28. I'll be using 0.2 for this printing. And the infill, which I'll explain later, is how hollow or how solid the inside of your print should be. So when you take this model, inside can be hollow and then the outside will look solid. So you can change this to 100 if you want the material you want to print should be solid, and you can change it to something like this if you want inside to be hollow. When it is solid, it is very durable, but it takes a longer time to print. And if it is hollow, it's not very strong, but it takes less time to print. So this adjustment is a trade-off between quality of print and the time that it will take to print. We also have the gradual infill option over here. And then the next thing we have here is the support. So if part of what you are modeling is going to be hanging in the air, you need to support it. So you can click on this one to support. And then adhesion is if you want the 3D printer to help you stick your model a little better to the print surface or the bed. So these are the settings I have chosen. Now, under here you have this option called the slice. The slice simply helps you to convert this to motor movements. And then you can navigate around the 3D interface of Cura using this. So this is kind of like the view cube of Cura. The next options I have here can be used to modify the model. The first one here can be used to move the model in the various axes. The second one here can be used to scale the model if it is too big or too small. The third one here can be used to rotate the model. And then you can also mirror your model using this particular option. And you can also use this one to, I don't know. All right, so I'm going to slice this. So I'll click on the slice icon here. And then it tells me that it will take 2 hours, 33 minutes to print, which is too long for me. So what I'll do is I'll scale this down to a smaller version of it to reduce the time that it takes to print. So I'll choose this guy, and then I'll change it to 60% of its current size. And then you notice that it becomes smaller, and then the slice time changes. So I click on slice again, and I'll get 50 minutes of print time, which is quite good for me. So the next thing I'll do is to take an SD card and then slot it into my machine and then save the model to it. So you notice that it generates something we call gene code. Gene code is a standard for specifying motor movements in engineering. So I'll save it to my SD card, and then I can take it to the 3D printer.
The next thing I will do
is to take the SD card from my computer and then insert it into the card slot of my 3D printer like this. After that, I'll go to the navigation panel over here, click on the rotary encoder here, and then I'll select print from TF. After that, I'll press on refresh, and then I'll select the gear that I have programmed it on my computer. We will need to wait for some time for the bed of the 3D printer to heat up, as well as the extruder. So whilst it is heating up, warming up, let me take my time to explain the various parts of the 3D printer. The first part here is the bed. This is the bed. The bed is where whatever you want to print will be located. So this is the bed. The bed can move forward and backward. And the forward and backward movement is the y-axis. The next part is the extruder. You notice there is some copper-like metal under. You are not able to see it. But this copper metal under the machine heats up to about 200 degrees Celsius. And this plastic filament, which is on this spool, passes through here, and then when it gets to the end of the extruder melts it and then deposits it whilst the machine is moving. You see that shortly. Now, this 3D printer understands only motor movements. So it has 3 motors, and those 3 motors are the motors that move the machine on the various axes. The first motor is this one. This motor is responsible for the X and then the Y axis movement, which is the same as the left and right movement. There is another motor down here, this motor here, which is attached to this threaded rod, and the threaded rod is responsible for moving the machine up and down in that order. I tried doing it for you to see. And then the next motor is this one. This is responsible for moving the bed forward and backward, forward and backward, forward and backward. And then this is the power supply. And then this is where you turn it on. And then this is the screen. The screen is where you can control the various parameters. So at the moment, the bed has warmed up to 60 degrees, and then the extruder is now heating up. It needs to go all the way to 200 degrees Celsius before the printing can start. So let's wait for it to do that. So our print has started. It will first print this layer, which is called as adhesion layer. After that, then it will start printing the actual gear. So let's see how it does that. Great. So you can see the outline of the gear showing partially. So to continue doing this for the next 46 minutes until it is done depositing this plastic all over that outline that we have created for it. So one thing you should note is every layer of plastic that it deposits is 0.2 millimeters thick. So it will keep cross-hatching like that till it is done printing. And then after that, it will add 0.2 millimeters to the layer height. So you can see what it is doing now. So our job is now 11% done, and this is where we have gotten to. So it will continue doing this till it is high, it is big like this, and then it will have the principles of design printed right on top of the gear. It will continue doing that till it becomes like this, and then I can just peel it off like the way I did earlier. I use this 3D printer to make this clamp. You know, during the lockdown I needed a clamp at home and I wasn't able to go to campus, so I just printed one and then I use it to clamp things at home. It works perfectly well. Our job is now at 60% and the layer height is now 5 mm, and this is the result. So you notice that the gear is not a very solid gear. It is having this cross hatch in the center of it. The cross hatch helps the printer to print the gear for us very quickly. So the cross hatch is called infill. When you make the infill to be 100%, there will be no cross hatch, but when you make it a percentage lower than 100%, inside of whatever you are printing will be hollow. So this thing that I'm having here is hollow, inside is hollow, but then you will not notice it until you cut a cross section of it. So this is what the printer does before it will cover it up nicely and then print the POD on top. So our job is now at 83%. Layer height is now 6.8 millimeters, and it is now putting the POD, principles of design, embossment onto it. So it is now with the main stock gear and it has covered it up nicely, and it is now putting the principles of design on top of it. So we have roughly 3 minutes more and we are done. So it is now done printing, and this is the result. The final layer height is 18.6 millimeters, and the machine has now moved to the home position, and I'm now coming to peel this off. So this is the result of the 3D printing that we have done. So it's an actual piece of plastic, and it is very hard and you can actually use it. So I have 2 of these gears which are printed. So this is what you were actually trying to do the other day with the assembly.